Hello and welcome back. For this video, we're going to talk about rational exponents. The goals that we have here: rewrite expressions involving nth root and rational exponents. Rewrite expressions involving powers of nth roots and rational exponents. We have quite a few vocabulary here, so we're going to define those on the next page. All right, so we've got a rational exponents. Now that's an exponent that's expressed as a fraction. So if you take a look right here, we have 64 to the 1/2 power. So if I did, let's say, 8 to the 1/3 power, that would be another rational exponent, because this number right here is expressed as a rational number, which for our purposes right now is just a fraction. Nth root is a little tough to explain, so we have an example here. So if a to the third equals b, then a is referred to as the cube root of b. So if we have a to the nth equals b, then a is the nth root of b. All right, so as far as index, radicand, and radical symbol go, the radical symbol is this part right here, and the index is the number that goes right here. It tells you which root you're finding, so that's the nth root. So if I put a little in there like that, that represents nth root. And the radicand is the number that goes underneath. Now the number that goes here in the index is needed for anything other than a 2. All right, so the first rule here is the power of 1/2. So for any non-negative real number b, if I have b to the 1/2 power, that's equivalent to the square root of b. So b to the 1/2 is equivalent to taking the second root. So if I put an index there, notice that the 2's here sort of match. You'll need to know that for the future here. So I got square root of b. Now if we want to talk about nth roots, for any real number a and b and any positive integers, so we got to make sure we have positive integers of n here. If a to the n is equal to b, then a is the nth root of b. So we've got a to the n is equal to b, then a is equal to the nth root of b. That's what we're talking about. Because 3 to the 4th equals 81, 3 is the 4th root of 81, and we put a little 4 in our index, and we end up with the 4th root of 81 equaling 3. All right, now we're going to take a look at rational exponents. And you can see here it says for any non-negative real number b and any positive integer n, so the denominator's got to be positive, b to the 1 over n has got to equal this nth root of b, so the nth root of b. So the denominator here represents the root that you're about to take. So we have 32 to the 1/5 over here. So since I have a 5 in the denominator here, that means I'm going to be taking the 5th root of 32. Now if you expand 32 into its prime factors, you'll see that it comes out to 2 5 times. So another way of writing that would have been to take the 5th root of 2 to the 5th power. Since you see that that equals 2, what we can surmise about this is that a 5th root will undo powers of 5, which means if I have a 3rd root and a 5 to the 3rd, then the 3rd root should undo powers of 3, which would give me 5. Now they want us to write radical and exponential forms, so we're going to write each expression in a radical or exponential form. So whatever form it's in, we're going to do the other form. So right now we have an exponential form because I have 10 to the 1/2 power. So we're simply going to write that as the square root of 10. And we don't have to put anything in the index position, but if you want to, you can go ahead and put a 2 there. On this next one here, we have a square root of 7k to the 2nd. And since everything under the radical, everything that fits under this bar right here, that's what's actually going to be taking the square root of. So we need to put parentheses. That bar kind of acts like a grouping symbol. So we're going to put parentheses, put 7k to the 2nd on the outside. And let's not forget that a square root is really 1/2 power. So we need to put a 1/2 power on the outside. All right, so once more, we're going to write each expression in radical or exponential form. So remember, if I have a group underneath the bars here, that's like, remember the bars is like a grouping symbol, so I want to put parentheses, and everything under the radical symbol or under that bar is going to be inside. So I have 16p. Now I'm going to write this as a fractional or rational exponent, so that would be 1/2 power. And then I'm going to distribute to simplify it a little bit. So the 1/2 power distributes to the 16, so I get 16 to the 1/2 times p to the 1/2. And technically 16 to the 1/2 power, since it's a square root, can be reduced to 4p to the 1/2 power. because the square root of 16 would be 4. Now, it did not ask me to go and rewrite those in simplified form. So this next one, we have 34, and it's raised to the 1/2 power. And 1/2 power, again, is a square root, so the entire 34 will go underneath. And once more, I don't have to put a 2 here, but I'm going to put 1 just as a reminder that the index there is a 2. This last one has a radical and a non-radical, so the 8 is just going to stay as an 8. The radical here only applies to the p, so I'm going to raise p to the 1/2 power, which is the equivalent of square root, and this ends up being our answer here. So down on this last one, you see we have parentheses with the 1/2 power here. So 1/2 power again is square root, so I'm going to write my square root. And since the 3p is inside the parentheses, all being affected by the 1/2 power, then the 3 and the p are under the radical. If for some reason there was another number outside, let's say a 5 on the outside of the parentheses, this 5 would go on the outside of the radical. It would not be inside. Now they want us to evaluate nth roots. So nth roots, right here I have a 5th root. That's what that means. Nth root here is 5, so n equals 5. In order to evaluate this, I need to know what 243 is, the square or the 5th root of 243. So I'm going to write 5 right here. And 243 appears to be 3 times 3 times 3 times 3 times 3, which is really the 5th root of 3 to the 5th power. And remember what I said earlier is a 5th root will undo powers of 5. So since those cancel each other out, like multiply undoes divide, I end up with just 3. Now I've got the 4th root of 625. So the 4th root of 625, and I believe that one is 5 times 5 times 5 times 5. Or in other words, it's the 4th root of 5 to the 4th power. And the 4th root will undo 4th powers and vice versa. So this just comes out to 5. So now we're going to evaluate exponential expressions with rational exponents. So to evaluate 4096 to the 1/6 power, that's equivalent to the 6th root of 4096. And I believe 4096 is 4 times 4 times 4 times 4 times 4, which would be the 6th root of 4 to the 6th power. And this 6th power is canceled by the 6th root, leaving us with just 4. Part A here, or letter A, we have a 1/4 power outside on a fraction. So this is the power of a quotient. And remember that rule there is to distribute the power. So I can write that as 81 to the 1/4 power over 256 to the 1/4 power, which means I have a 4th root of 81 in the numerator and a 4th root of 256 in the denominator. The 4th root of 81, well, 81 is actually equal to 3 to the 4th power. And 256 in the bottom here, so the 4th root of 256, and that's equal to 4 to the 4th power. All right, so on top I have the 4th root of 3 to the 4th. The 4th root cancels with the 4th power of 3, so I end up with a 3 on the top. And on the bottom, the 4th root cancels with the 4th root of 4, so those cancel, leave me with just 4. So this entire expression at the beginning just simplifies to 3/4. Down here I have the 5th root of 100,000. And I'm pretty sure that 100,000 is really 10 to the 5th power. And the 5th root's going to undo the 5th power, leave me with just 10. Now we're going to talk about powers of nth roots, okay, for any real number b and any integer m, and n, where n is greater than 1, because you can't take the negative radicals again, so the denominator here has to be positive. If I have b over m to the nth, that's equivalent to the nth root of b raised to the nth power. Or we could have the nth root of b to the nth power. So the m could be on the inside or the outside. So the m here, the m is acting like an exponent, and the n is acting like a root. And that's how you want to remember those. So 216 to the 4/3 power, the 4 here is going to go as an exponent on the outside, at least in this context, and the 3 here is going to go as an index or root. So the cube root of 216 raised to the 4th power. Well, the cube root of 216 is 6, and then 6 is then raised to the 4th power, and you end up with 1296. We have the next one is 32 to the 2/5 power. So the 2 is going to be the exponent and the 5 is going to be the root or the index of the root. And notice that we have the 5th root of 32 to the 2nd power. So the power is on the inside this time instead of the outside like the last one. So when we do 32 to the 2nd power, we get 1024. And then, of course, the 5th root of that is 4 to the 5th power. And the 5th power is canceled out, leaving just 4. Now, I want to point something out really important here. Let's go back to the beginning here. The first one had 216 to the 4/3 power. The 4/3 is bigger than 1, so we're raising 216 to a power bigger than 1, and notice the output was bigger than the 216 that you started with. The next one was 32 to the 2/5 power, and the 2/5 is smaller than 1, and the output was a number smaller than the 32 that we started with. That pattern is going to hold true at all times. Now we're going to evaluate some expressions of powers of nth roots, and 729 to the 5/6 power. Now the projection here, since this 5/6 is actually less than 1, I should get an answer that's smaller than 729. Now, which one do I do first? Do I do the power of 5 or do I do the 6th root? That depends on the number here. I believe you can take the 6th root of 729, so I'm going to do 6th root of 729. And then raise that whole thing to the 5th power. So the 5 is the exponent, and the 6 is the index or the root. So let's go ahead and simplify. So the 6th root of 729 is 3. Then I got a 3 raised to the 5th power, and 3 to the 5th power is going to end up being 243. And you can see that this number is smaller than the number we started. For this bottom one, we're going to first distribute this exponent to both the numerator and the denominator. So we have 36 to the 3/2 power over 49 to the 3/2 power. And I need to decide if I'm going to do the root first or the exponent first. So the root is the denominator and the exponent is the numerator. If I look at my number, I'm taking 36, and if I do a square root of that, that's easy for me to do. So I'm going to do the square root of 36 first, and then raise it to the 3rd power afterwards. And the same thing on the bottom. I have a 49, and if I do the square root of that, I can do that in my head. So square root of 49, and then I'm going to put the 3rd power on the outside. Now, the 2 didn't go anywhere. The 2, remember, is the index here on the radicals. We just don't have to put the 2 if we don't want to. Now, the first thing is going to be the square root of 36, which is 6. I still have to raise it to the 3rd power. And the square root of 49 is 7, and I still have to raise it to the 3rd power. And then we've got 6 to the 3rd power, and that's going to give us 216. And then we've got 7 to the 3rd power, and that's going to give us 343. And this is our final solution. So for our last example, we're going to apply rational exponents. For insects, the resting metabolic rate can be determined by the formula R equals 4.14 m to the 2/3 power. One thing you need to be aware of here is the 2/3 power only affects the m, where R is the resting metabolic rate in milliliters of oxygen per hour, and m is the body mass of the insect in milligrams. Determine the resting metabolic rate of a 125 milligram ebony juling damselfly. So in place of m, we're going to put 125. So R is going to equal 4.14 times, and I'm going to put this next one in parentheses, 125 raised to the 2/3 power. Now the 2/3 power means take the cube root of 125 and square it, or vice versa. I happen to know what the cube root of 125 is, so I'm going to do that one first. So 4.15 times, and then I'm going to do the cube root of 125. Then I will raise that to the 2nd power. So we still have to follow order of operations here. So we're going to do the cube root first, 4.14 times, and the cube root of 125 is 5. And then I still have to square it. And 5 squared is going to give me 25. So I have 4.14 times 25. And I will end up with a resting metabolic rate of 103.5. And that's milliliters of oxygen per hour.